All right, folks, today you are going to be continuing your work with the laws of exponents. So up first here, I have some problems where we're just going to kind of review the basics. The problem that you see on your screen right now, you know, is an example of the product rule. It's a product rule because I have two sets of parentheses side by side that are being multiplied together. So I have coefficients of 12 and 3/4. I have a to the second and a to the third. And then I have b to the second and b to the fourth. And again, you know, like I told you yesterday, you don't have to write it all out the way I am right now. But I just want to kind of break the problem down for you and make sure you understand how this works. All right, so with the coefficients, I'll do 12 times 3/4. If you use your calculator and do 12 times 3/4, you're going to get 9. With exponents, in product rule, I add. So I'm going to have my a, and I'm going to add 2 plus 3 to make that a to the 5th. I'm going to have my b, and then I'll add 2 plus 4, which is 6. So the answer to this problem should be 9, a to the 5th power, b to the 6th power. Now, as we talked about yesterday, can that be my final answer? Yes, it can, because it has positive exponents. There's no zero powers, there's no negative powers. So in your product rule, you multiply your two coefficients, and then for each variable, you add your two exponents. So that's my product rule. All right, here you see an example of the power to a power rule. I know it's power to a power because I see parentheses and then this exponent on the outside. So I have a coefficient of -3 that needs to be raised to the third power. I have x to the 6th power that needs to be raised to the third power. And I have y to the 4th power that needs to be raised to the third power. Again, just kind of breaking that down for you. Now, if I use my calculator and I do -3 to the third power, I'm going to get -27. And then for power to a power rule, we know that we multiply these two exponents together. So for x, we'll do 6 times 3 and get 18. And then for y, we'll do 4 times 3 and get 12. So the coefficient gets raised to the power on the calculator, and then for each variable, we multiply the two exponents together. So this is going to be -27, x to the 18th, y to the 12th. Now, that's an answer, but can it be my final answer? Yes, it can, because none of the exponents are 0 and none of the exponents are negative. So that problem would be done. All right, here we see an example of the quotient rule, and we will recognize that this is quotient rule because it is a division problem. There is a fraction bar. Okay, so I have my coefficients, -24 over 8. I have my p's, p to the 20th over p to the 4th. And then I have my q's, q to the 18th over q to the 12th. So those are the three things that I have to deal with. Now, right here, this says to do -24 divided by 8. I can do that part in my calculator, and I know that's going to give me -3. With quotient rule, we subtract the two exponents on the p's, so we're going to have p to the 20 minus 4 power, which would be p to the 16th. And then for q, we will also subtract the two exponents, 18 minus 12, and get 6. So this answer would be -3, p to the 16th, q to the 6th. Can that be my final answer? Yes, because there are no 0 exponents, no negative exponents. So those three problems, just a quick basic reminder of what to do with each rule. Now, here you see another quotient rule problem. So I've got my coefficients, negative 42 over 6. I have my w's, w over w to the third. And I have my v's, v to the 8th over v to the negative 2. Now the coefficient part says to do negative 42 divided by 6, which gives me negative 7. For the w's, I'll subtract the two exponents. This is 1 minus 3, which is negative 2. And then be really careful on this last one, because for the v's, look what you're subtracting. You're subtracting an 8 minus a negative 2. It's not 8 minus 2, it's 8 minus negative 2, which is going to give you v to the 10th power. Be really careful with those signed numbers. So for this division problem, we're going to end up with negative 7, w to the negative 2, v to the 10th. Now, can that be my final answer? This time, no. And the reason that this can't be my final answer is because of this right here, because of w to the negative 2 power. All right, I can't have a negative exponent in a final answer, so I know this requires a fraction bar. Now that w to the negative 2 is going to drop to the bottom of the fraction, so you'll have w to the 2nd power down here. Notice he loses that negative when he drops to the bottom, but then the negative 7 and the v to the 10th will fill in the top. Now that negative 7, notice, is allowed to be negative because he is a coefficient and not an exponent. Coefficients can be negative. So there's an example that shows us what happens when we have those negative exponents. All right, so that's enough of a reminder of how each individual rule works. Today, what you're going to do, and I kind of previewed this a little bit yesterday with those of you who were here, we're going to be doing multi-step exponent problems. And in these problems, what happens is you may have to use all of the exponent rules that we learned in order to get your answer. So these problems won't be just one thing, they can be many things. Now when you're doing multi-step exponent problems, the key is to look for the 3 main exponent rules in a particular order. So when you look at these problems, the first thing I want you to ask yourself is power to a power in the problem? And remember what that would require. That would require that there be one set of parentheses with an exponent sitting on the outside of it. So is power to a power there? Because if it's there, you're going to have to do that first. Okay? After you have done power to a power, the next thing you're going to do is ask yourself, is product rule in this problem? And remember, for product rule, what you would have is 2 sets of parentheses being multiplied together. Or sometimes they don't even put the parentheses, they just put the little dot for multiply in there. Okay? And then third and final, you will ask yourself, is quotient rule in my problem? Okay, and if quotient rule is in your problem, you'll recognize it because there will be a fraction bar with part of the problem on top and part of the problem on the bottom. So you need to look for the 3 rules in this order and do them in this order. Now they may not all be there, and if they're not, just skip that part. But then always at the end, remember to look at your answer and say, is that my final answer? Okay, so I'm going to write that in here, I think. Is that my final answer? And remember, that's where you take care of any 0 exponents or any negative exponents that may be there. So I would recommend that you pause the video right now and write this set of 4 steps on your paper so you'll have it to kind of go by, because this is the order that you need to look for things in. Okay, so now let's take this and let's do some problems. All right, so here is a multi-step problem. The first thing I'm going to do is I'm going to look for power to a power. Is it there? Do I see any parentheses that have an exponent on the outside? And the answer is I do. Right here is power to a power. So I'm going to focus all of my attention on that and do that right now. Now, you don't have to do this again, but I'm going to write it over here as its own problem so we can kind of focus in on it and get it done. So I'm going to take my coefficient of -6 and square it. I'm going to take a to the third and square it. And I'm going to take b to the second and square it. So -6 squared, if I do that on my calculator, will give me a positive 36. Don't forget to use your parentheses. And then for a, we will multiply the two exponents together. And for b, we'll multiply the two exponents together because that's what we do in power to a power. So up here on the top, we're going to have 36, a to the 6th, b to the 4th. So I've done this. And that's what it's become. And now I'll just carry the rest of the problem down. So the fraction bar and the 4a to the 4th, b to the 11th. So now this is my new problem. So the second thing I'll do is I'll look for product rule. Do I see two sets of parentheses being multiplied together? Well, I don't know about you, but I don't see that in this problem. So this is a no. I don't need to do the product rule. He's not there. So then I move to that third step. Is quotient rule here? Do I see dividing going on? And the answer is yes, I do. This is a division problem. The whole thing is a division problem. So I've got coefficients of 36 over 4. I have a to the 6th over a to the 4th, and I have b to the 4th over b to the 11th. So I'll divide. 36 divided by 4 is 9. And then I know in quotient rule I should be subtracting these two exponents that are on my variables. So for a, we're going to do 6 minus 4, which is 2. And for b, we'll do 4 minus 11, which is -7. So now this is done. And I have an answer. I've done all three of the major rules. I got to skip product rule because it wasn't there. Now, what I do at this point is I look at that and I say, okay, I've got an answer. Can it be my final answer? And the answer this time is no, it can't, because right here I see this negative exponent. So that tells me I'm going to need a fraction bar to end this thing. b to the -7th will drop below that fraction bar. So that will become b to the +7 down here on the bottom. And then my two parts that were okay, the 9 and the a squared, will fill in the top. So there's our first example. And what I want to point out is that we are doing the same individual rules that you've been practicing now for a few days, but we just have to kind of take this one step at a time. Look for each of these different rules in the problem and do them one at a time. Now, remember here that all I'm asking for is that you try this. I know this is a lot, but I'm asking that you try it, and then Monday when I get back, if you struggled, we'll fix it. Okay, so here is a second problem. All right, for this problem, the first thing I'm going to do is look for power to a power. Do I see parentheses with an exponent outside? And I do. This rule is there. So I'm going to take care of it. Now what you'll notice is, here is power to a power. That's one of them. But there's also another one. Here is power to a power. Both of those are parentheses with exponents outside. So we're going to have to do both of these right now. Okay? So let's start over here. Start with your coefficient. You need to do this 3 raised to the second power. So 3 raised to the second power is going to be 9. Now, for each of these variables, we have to do something to exponents. So what we know we do is we multiply the two exponents when we're in power to a power. So for W, we're going to do -7 times 2, which is -14. And for V, we're going to do 1 times 2, which is 2. So this part is done. Now we'll do this part. We've got a coefficient of 2. That needs to be raised to the 5th power. So 2 to the 5th power is 32. And again here, now I need to deal with my variables and exponents, and since this is power to a power, I'm going to multiply the two exponents together. So I'll do 3 times 5 for W and get 15. And I'll do negative 4 times 5 for V and get negative 20. So after I complete both of my power to a powers, here's what my problem looks like. So next up, I'm going to look for my product rule. Do I see two sets of parentheses multiplied together? I do. So now I'm going to do this product rule problem. So I have coefficients of 9 and 32. So I'm going to do 9 times 32. I think that's 288. Just right off the top of my head. 9 times 32, 288. Now, I have to deal with my exponents. This is product rule. So in product rule, I know I add the two exponents together. So for W, I'm going to do negative 14 plus 15, which is a 1. Now I'm going to leave that invisible. And then for V, I'm going to do 2 plus negative 20, which is negative 18. And so now my product rule is done. And I think you'll be able to see from this problem that when I check for quotient rule is a no, because there is no fraction bar in this problem. So I have an answer. Can it be my final answer? No, it can't, because I see this negative exponent here. So fraction bar comes in. My V is going to drop below that fraction bar and become V to the 18th power. On the top, I'll have 288 and W. And that is my final answer. So notice again, you're using the rules, more than one of them, and it's just a matter of looking for them one at a time and taking care of them one at a time. Just kind of checking those boxes off until you're done. Okay. Let's go ahead and skip over and do this one next. So notice this problem looks a little bigger. We're going to start by looking for power to a power. Anywhere in this problem do we see parentheses with an exponent outside? And I think you would agree that we do. It's there, so we're going to have to do this. So right now, this part of the problem is what I'm going to do. I'm going to leave all the other stuff alone and just do that part that I just highlighted. So I've got a coefficient of negative 8. It needs to be squared, so I need to do negative 8 squared. Well, a negative 8 squared is a positive 64. Now, I'm going to have to do something with these exponents. This is power to a power. So I should multiply two exponents together. So for x, I'm going to do 3 times 2 and get 6. And for y, I'm going to do 2 times 2 and get 4. So 64, x to the 6th, y to the 4th replaces what I had highlighted here in yellow. Now all of this other stuff that I see now needs to move down. So beside that, I need to have times 2 x squared y to the 6th. And then all of that is over 32 x to the 8th y to the 3rd. So here is my new problem. So now I'm looking for product rule. Do I see multiplication going on? And I do. And again, that multiplication is happening up on the top. So this is the next part of the problem that I'll do. So I've got coefficients of 64 and 2, and this says to do 64 times 2. So 64 times 2 is 128. Now I deal with my x's and y's, and I'm going to add exponents. This is product rules, so I add exponents. So for x, I'm going to add 6 plus 2 and get 8. And for y, I'm going to add 4 plus 6 and get 10. So 128 x to the 8th, y to the 10th is going to replace this product rule problem on the top. This part needs to move down. So third, I need to check this for quotient rule. Do I have dividing going on? And the answer this time is yes. So I'm going to start with coefficients right here. This says to do 128 divided by 32. 128 divided by 32 is 4. Now I deal with my variables. And since this is quotient rule, I should be subtracting 2 exponents for each variable. So for the x's, I'm going to do 8 minus 8, which is 0. And for the y's, 10 minus 3, which is 7. Now I have to look at this and say, okay, I have an answer. Can it be my final answer? And this time it's no, because of that x to the 0 power. Now we know that means x is repeated 0 times in the answer, so he just goes away. So on this problem, your answer should be 4y to the 7th. So to summarize what you're doing here, look for power to a power first, product rule second, quotient rule third, and then look to see if your answer can be your final answer. Are there 0 or negative exponents involved? If not, then you're done. If those negative and zeros are there, then fix it. So use these examples. Give the problems that I've left for you today a try. Get as many done as you can. Remember, all I'm looking for is effort. So if you struggle, make a note of which ones you're having trouble with on the paper. Write me some notes on there, and we'll take care of those questions when I get back on Monday. Thanks.